Care and professionalism during the concrete installation process has the biggest effect on the quality of the finished slab one will get. For details not discussed within this presentation, please refer in the first instance to the HERA report, R4107-2005, Composite Floor Construction Handbook. Updates to the R4107 document covering recent learnings about floor flatness and levelness are covered in the Steel Advisor documents CMP 1004 and CMP 1005, available from Steel Construction New Zealand. Please also note the concrete standard NZS 3101 focuses more on general concrete and ground slab tolerances. R4107 and the CMP updates deal with the specialist nature of suspended concrete systems and what one can expect from this unique building system. There is a key point to remember whenever working with concrete. Any and all concrete will crack. It's just to what degree. Cracking can be reduced by adding more reinforcing to distribute the stresses more efficiently. Controlling the water content. As water evaporates, the concrete shrinks. More water equals more cracking. Controlling the rate of curing. The faster the concrete dries out, the greater the rate of shrinkage, and of course, the larger the cracking. It's also important to understand what design has been used. Is it propped, unpropped, single or multiple span sheets? Are the beams pre-cambered? Is the slab to be poured to thickness or screeded to level? If in doubt, ask. All suspended slab systems deflect under load. Firstly, during construction, and again once in service. Whether designing or constructing a ComFlor slab, consider what deflections and surface finish are likely and what is achievable and acceptable. Although ComFlor can span vast distances, a consequence of utilising this capacity is that larger deflections may occur, both in the ComFlor and the beam system due to the wet concrete load. To control these deflections, the following points should be considered. Never heap concrete other than what is required to achieve effective screeding. Avoid shock loading the ComFlor. No matter whether a skip, boom pump or line pump is used, the concrete should be released no more than 300 mm from its final resting place. It's useful to think of the ComFlor sheets acting as a seesaw. Spread the load evenly and you reduce the deflections on each side of the beam. It should be noted that the seesaw effect only applies where the ComFlor continues over both sides of the beam. Where the ComFlor joins on a beam is treated slightly differently. Another factor that will affect deflections during the pour is the human loading while the concrete team pour the slab. It's recommended that a 1 metre working zone is maintained to minimise local overloading. By following these few simple rules, site safety is improved and the volume of concrete used is reduced. This can only be good news for those paying the bills. Concrete pour sequencing has a definite effect on the deflections one gets from a suspended steel deck design. The following advice and techniques will not be required for every job. They get more important as you near ComFlor's span limits. When used, this guidance will reduce both deflections and concrete usage. For best results, please contact your ComFlor representative for advice on your particular project. A good rule to start with is the 1/3 rule. That is, from each beam, one pours 1/3 into each span, leaving the middle third of the span unpoured initially. The resulting empty 1/3 zone between the beam strips can then be poured, using the existing concrete as screeding guides. The exact width of the concrete strips over the beams versus the strip left unpoured will vary slightly from project to project as the beam size, span, pre-camber and the ComFlor span will vary, but the basic principle will always apply. A risk when using pre-cambered beams is the concrete ends up thinner than designed in the middle of the beam span. To avoid this and achieve the minimum designed slab thickness, height indicators are best used along the beam. These can be either pads of concrete or height gauges fixed to the beam and is termed pouring to thickness. In theory, any pre-camber in the beam should flatten once the concrete is poured. The resulting slab will look something like this. The designed thickness over the secondary beams with some thickening in the ComFlor slab spanning between the beams. Putting all this together, we see the pour is started as usual at one end of the building, but is broken up into bays. A bay is determined by the length of the individual ComFlor sheets. A strip of concrete is poured over the first secondary beam in from the building edge, using the 1/3 rule. Each secondary beam zone is loaded first, and then the gap between is filled. In all bays, the last section poured will be where the ComFlor sheets join on a beam, as these zones are the most prone to deflecting. Due to the great spanning capabilities of ComFlor, it's been found that ComFlor 60 is typically installed as triple or continuous span sheets, and ComFlor 80 as double span in construction. This equates to ComFlor sheets of approximately 12 and 9 metres respectively. Again, a reminder, this sequencing is only important when concrete usage and underside deflections need to be strictly controlled, and is more vital as the design nears the upper limits of ComFlor's unpropped spanning capability. In most cases, however, the traditional method of starting at one corner and spreading from there will suffice. As long as the general overloading and concrete placement rules are followed, the ComFlor will give excellent results. Some safety advice. If excessive concrete usage or deflections are observed, stop and assess the situation. It may be that the ComFlor is overloaded or overspanned, or the propping is not working properly. Perhaps it's broken. Perhaps you forgot to install it. If in doubt, stop and prop. Please do not keep pouring concrete if excessive deflections are noticed. Other important factors to ensure the best results from your ComFlor slab are: before the concrete pour, avoid dropping or stacking heavy items onto ComFlor. Loads must be spread so as not to damage the ComFlor, risking collapse during the pour. And any damage to the ComFlor is highlighted for repair. Remove all dirt and debris from the ComFlor to ensure proper bonding with the concrete. During the concrete pour, use a maximum of 100mm slump concrete. This will greatly reduce shrinkage cracking. Water must not be added without clearance from the design engineer, as it can result in excessive cracking and reduces the structural performance of the slab. To consolidate the concrete and remove unwanted air, a pencil vibrator is best used. After the concrete pour. For best results, the concrete must be cured. Otherwise, excessive and random cracking can occur. For best results, keep the slab constantly damp for 7 days. The curing or wetting process should be started as soon as the concrete is hard enough to resist surface damage. Hot and especially windy days should be avoided when concreting, as these can dry the fresh slab too fast, increasing the possibility of unsightly cracks. Leave any propping in place for the full 28 days, otherwise extra deflections and plastic creep will occur as the partially developed concrete copes with its own weight and construction loads. Experience and specific studies have shown there is no need or reason to cut a suspended slab. The dynamics of crack inducement in a suspended slab differ greatly from that of ground slabs. The crack control of a ComFlor slab is achieved by good concrete practice and using reinforcing relative to the cross-sectional area of concrete slab and the size of the cracks considered acceptable. Construction joints are often required on larger sites. A construction joint should be positioned so that the dynamics of any composite design is not negatively affected. Full guidance on construction joint placement can be sourced from HERA Report R4-107-2005. A good general rule is to locate the construction joint 600mm back from the centre of the beam, and at a beam where the ComFlor sheets join. That is, where they do not continue over the beam. This way, the beam will develop its stresses as naturally as possible, and the shear studs will acquire a full bond with the fresh concrete. For more detailed information on the techniques outlined in this presentation and the benefits of structural steel in general, please contact us in the first instance at www.comflor.co.nz. Thank you for taking the time to view this presentation. We look forward to helping you with your next ComFlor project.